Thermodynamics. Today we will talk about thermodynamics, which is derived from the two words. The one word is the therm, which means heat. The other word is dynamics, which means in motion. So the literal meaning of the term thermodynamics is the study of flow of heat or heat in motion. So it means that actually it will deal a relationship between the heat and work, and it also includes the all kind of interconvergence of the energies. So when we are talking about the thermodynamics, we will here use some basic concepts. Let's clear them. What is meant by system and surrounding? The part of the universe that is chosen for thermodynamic consideration or observation or experimentation or study, that the effects of the temperature, pressure or any other factor is called the system. Means that any part of the system that is specified to be studied, to be focused under the effect of different factors will be called as the system. So the remaining part of the universe other than the system is called the surrounding. There are three types of systems. Number one is open. What is meant by open system? If a system can exchange both matter and energy with the surrounding, for example animals and plants, this will be called as the open system. The animals and plants are exchanging matter and energy with their surrounding. It is very clear. Example is excretion process. For the matter exchange, for the intaking means that digestion, or intaking mean the ingestion of the food. So in case of the energy transfer means that we use our mechanical energy, we use our muscle energy for the transfer of the things, for doing work, for writing, for walking. That means that we use the energy in different forms, and sometimes we also often use our energy for the formation of the sound. So means that the energy is being converted. So the second form is closed system. If a system can exchange only energy with the surrounding but not the matter, so this will be called as a closed system. Example will be a water placed in a closed metallic vessel. The third type is isolated system, in which neither exchange of energy and nor exchange of the matter is taking place with their surrounding, for example thermos flask. Okay, now we will study different laws of thermodynamics. Let's talk about the zeroth law. This law states that if two systems, A and B, are in thermal equilibrium with the third system, C, then A and B will also be in thermal equilibrium when placed together. What does that mean? This means that when two systems, for example, one system name is A and other system name is B. So when these two systems are placed together and these are having the energies or heat that is equilibrialized, or that is equilibrium, or that is equal to the energy of the third system, it means that at that point we can say that the C system is also having the equilibrium or the same or equal energy with the A and B. The diagram is representing this concept very well, where we are saying that A and B is in equilibrium, B and C is in equilibrium. As we say that when the A and B, these two parts are with equilibrium, and when we say that these two are also in equilibrium with C, it means that these are also equilibriumized separately with the C. For example, we can say that A is in equilibrium with C, such as we have said before that A is in equilibrium with B. So here also B is also in equilibrium with C. All these three forms are in equilibrium with each other. Here graph is also showing us that with the passage of time, when the pressure decreases, the volume increases, and temperature is T1. When temperature is increased, then pressure is also decreasing and volume is increasing, and the volume increases higher as compared to the volume increase when the temperature is T1. Means that when temperature is higher, volume is also higher or increased. So when the temperature is more higher, means that the temperature is T3, in that case the volume is further increased. What does first law of thermodynamics say? The first law of thermodynamics is the law of conservation of energy. This law is a study of the human experiences. This law is a result of the human experiences. It is not based upon or derived from any principle. So this law statement can be given in this way, in various way. One of this way is that energy can neither be created nor destroyed, but if one form of energy disappears, it must appear in some other form in equivalent form. Means that total mass and energy of an system remains constant. What means that? Total mass and energy of an isolated system remain constant. Isolated system was the third type of the system where neither matter nor heat means energy was leaving the system. So the total energy of the system and its surrounding remains a constant. What does that line mean? That line means that when the energy is being removed or coming out or emitting out, it will go into the surrounding. In the result, surrounding energy will be increased. In the equal amount, the energy of the system will decreased. Means if -3 energy is coming out, so means that surrounding is gaining the -3. So means that in total, as a result, altogether energy remain constant. Means that if energy is released from the system, it's coming to the surrounding, so it's not going anywhere else, just it's changing its position, just it's changing its form. So it means that the energy can neither be created nor destroyed. It can be converted from one form to another, but in equivalent form, equivalent amount, or equivalent form, right? Okay, when we talk about the second law of thermodynamics, we will first clear our requirement for the study of second law of thermodynamics. What is the need to be introduced the second law of thermodynamics? Before that, when we have studied the zeroth law of thermodynamics, first law of thermodynamics. First law of thermodynamics was not capable to tell about the equilibrium position. It was not telling us about the equilibrium position, and it was not explaining the direction of the chemical reaction or the direction of the any process to be carry on in other way. And it was not telling the final equilibrium position concentration will go, and it was not telling about the relationship between the heat and the work. So it means that there are some limiting factors in the first law of thermodynamics that are needed to be addressed. So in this equation or in this derivation, second law of thermodynamics will help us to determine some basic concepts. It is possible to convert. Means that, for example, when we have said that the first law is telling us that energy can be converted from one form to another form, it's not telling that how much energy can be converted into another form, and it's not telling that when the heat is converted from one form to another, and that back heat is not completely capable to be converted into the work, because some of the energy will be rejected, some of the energy will go waste in friction, some of the energy will go waste in making the sound, some of the energy will go waste due to the some unskilled person, or due to the some instrumental problems. So the original statement of the second law of thermodynamics is much concerned on the development of the theoretical aspect of heat engines, especially that is all about the Carnot engine. That Carnot engine is the implication in chemical process not as much, but further development and the derivation will help us in the concept development of the law, and immense study of the chemistry. Means that immense helpful for the chemist to study the further processes or laws and some assumptions to be taken the chemistry forward. So for example, the direction of the particular spontaneous transformation can be ascertained with the help of the second law and is not predictable by the first law. So that was the reason why we are going to study the second law of thermodynamics. Most of the natural processes are spontaneous. In fact, all the human activities that are happening in the universe are the spontaneous. For example, the production of wheat from the seed, that is a spontaneous process. The formation of clouds in the sky, sunny day on the sunny day, because on the sunny day the water will be evaporated with the help of the wind. It will flow above and will be converted into the clouds. So the fall of rain as well is a spontaneous process. Multiplication of microorganisms where food is digested. All these are the spontaneous processes. So we can define the spontaneous process now. What does the spontaneous mean? All those processes which take place at their own accord are called spontaneous processes. Mean all that processes that take place by their own without the interference of the external agent are called the spontaneous process. One more thing to be clear here is that spontaneity does not mean the instantaneous. Means that it doesn't mean that it's a spontaneous process so it should be instantaneous. No, it can be in a stepwise. It can be a planned thing by nature, so it's not instantaneous but it is spontaneous because it's taking place by its own accord. Simple. Okay, here are some more examples that will convince us to know that why the second law of thermodynamics is important. The first example is when a plate falls on the floor, breaks into pieces and gets scattered. When we take ice cream, then our lips get cold. Water runs downfall always. A drop of perfume in a room diffuses quickly to enter into the entire home. Aqueous solution of sodium hydroxide react with ACl to form NaCl, and all these processes are known to be taken place in one direction, are spontaneous processes. And the question arises here that why these reactions don't go in reverse, why these reaction or processes don't go back. The reason or the explanation is given by the second law of thermodynamics, because we have never seen that the water is flowing from downside to upside without applying any external force, without applying any force agent. We have never observed that the gases, exhausted gases, carbon dioxide, carbon monoxide, and water that are present in the environment are recombined to form the petroleum product and oxygen. We have never seen that the broken plate pieces recognize themselves and get arranged into a plate again. We have never observed that when a person is taking in the ice cream and feel the hot. We have never observed such situations. So it means that we will study the spontaneous processes, the irreversible processes in the second law of thermodynamics. Okay, very important, highly asked question. Statement of second law of thermodynamics. At least two statements of the second law of thermodynamics you must learn. The number one is that no process is possible in which the whole sole result is the absorption of heat from a reservoir and its complete conversion into work. Means that not a work is possible in which the sole result should be the absorption of heat from the reservoir, means from the source, and completely converted into work, because it's never possible that they take heat from the reserve or from the resource and convert the fully heat into the work. Rather, some of the heat is wasted, because that is the truth, that is a fact that we will prove in the second law of thermodynamics. That definition is given by the Kelvin. Okay, another definition given by the Clausius. We will study about it. What does it say? It is impossible for a system to undergo a cyclic process where sole effects are the flow of heat into system from a cold reservoir and the flow of an equivalent amount of the heat out of the system into a hot reservoir. Means that not such a cyclic process is possible in which the heat is taken out from the cold reservoir and comes into the hot reservoir, and in the same amount or equal amount of the heat is evolved or emitting out from the hot reservoir. These two definitions are highly important, and if you want you can read this one also. This is also about the second law of thermodynamics. What is meant by the entropy here in the thermodynamics? There exists a function called entropy. You know, the randomness or disorderedness of a system is called the entropy. The entropy of the universe remains constant when a reaction is reversible. But we know that in the thermodynamics, we are talking about a system in which the reaction is going irreversibly, and that reaction or process is spontaneous. It means that once a thing is changed. One a process is occurred. One managed things are disordered. Once the entropy is disbalanced or increased is increased. It means that in an irreversible process, in a spontaneous process, the randomness, the disorderedness is increasing. So it means that in the spontaneous process, there is always a case to be observed that entropy of the universe always increases. Here is a short question that is highly important to be asked, and various time it is also questioned. The entropy of the universe always increases. Why? Because we have discussed and justified this thing that before that that the universe, most of the processes, most of the phenomena in the universe are the irreversible, are the spontaneous. So means that these are irreversible, and in an irreversible process the things are changed, the things are transferred, the things are combined, or the things are recombined. Whatever is happening is happened, and the reaction does not go back, the things does not get arranged again, like the plate pieces. So the broken plate pieces are broken, and these will not get arranged by itself to be arranged into a plate again. In the same way as in the universe, the processes are spontaneous, irreversible, means that the system disorderness is increasing, randomness is increasing. In the result, as the phenomena of all the cases, we can say that in the universe the entropy is always increasing, is always rising up, is always positive, is always increasing. So when we talk about the different phenomena or different factors that are very clearly explained in the second law of thermodynamics, what are these factors? Number one factor is the direction of energy. The second law of thermodynamics will help in direction determination of a reaction. So the second process is that it will help determine the spontaneity of a process. It will tell that the reaction or the process taking place is spontaneous or not. And it will also help us to understand the equilibrium position of a system that is not explained in the first law of thermodynamics. And it also help to find the maximum fraction, means the maximum amount of the heat that can be converted into the work, because not all the heat can be converted into the work. So it is telling us about the four major important factors that are essential to be determined to make the efficient devices, to make the efficient engines. So for the example of the for a general example for understanding of the second law of thermodynamics, we will study heat engine and its efficiency. That is just about your concept, that is just for your understanding. You should learn it as well. So basically it's for the concept building, and that will demonstrate the previous all the assumptions and all the discussions, or all the theses we have studied. So now we will say that the heat engine and its efficiency, how it will work. A device which converts heat energy into the mechanical work is called the heat engine. Simple. The heat engine which completely convert the heat into the work will be called the perfect heat engine, will be called the ideal heat engine, ideal, perfect. And the heat engine which cannot do this, which cannot completely convert the heat into the completely into the work, that will be called the real, that will call the actual heat engine. A real heat engine takes heat energy from a hot body and converts a part of this heat into the work, and rejects remaining part to the cold body. Construction is here in this diagram, you can see it very well. Here is the high temperature heat reservoir, means that a hot body, and T1, the Q1 is the heat flowing, and this is the system in circle form, that is showing that as a result output is obtained or work is obtained, W. And here Q2 is the heat that is rejected, or that is wasted, or that is not needed, or that is not worked out, that is not integrated, that is not used by the system, and is rejected into the lower temperature reserve, mean cold body, at the temperature T2. You must know that here the T1 is must be higher than the T2, as it is a high temperature body, it is a lower temperature body. So here the construction can also be explained that one is high temperature reservoir called source, and other is low temperature reservoir called sink, a working substance or a system. So working principle of heat energy is shown in this diagram, and it takes the heat Q1 from the high temperature body T1, it's coming to the system, it will work, it will get converted into the W, mean output, and the remaining energies or the heat is Q2, it's going back into the cold body to be stored, or that is also called to be sink. And how we can determine the efficiency of an engine. Efficiency means the how much heat it can convert from taken from the hot body or the high temperature reservoir into the work. The system or the engine that can convert as much fraction of the heat absorbed from the hot body into the work is more efficient. More is heat convertible from that engine, more it is efficient to be considered. And if it is not able to convert, or it is able to convert only small amount of heat into the work, then its efficiency is lower. Here we can say that the efficiency of an engine is the ratio of the work done by the system divided by the heat or the energy taken in, or the energy input, or the heat input, ratio of the work and the heat input. So when the work is obtained by the taking in the heat and rejecting the work heat, so it's all about W is equal to Q1 minus Q2. So when we take the denominator as separately on each numerator, so we get the equation in this form, Q1 cancels out the Q1, so it becomes the eta is equal to, that is showing the efficiency, eta is equal to 1 minus Q2 over Q1. And if we want to know the percentage, efficiency of heat engine, so we can write the equation in this form, where we are multiplying this above equation with the 100. Simple. That was all about the heat engine efficiency. And if we want to know, and if we want to get the 100% efficiency or perfect engine, so it means that in that case Q2 must be 0. What is Q2? Q2 is the rejected energy, rejected heat. If the rejected heat is minimized or is almost equal to 0, then at that case it will be 100% efficiency. So it is not practically possible.